Separate BM25 queries can misscore documents when terms split across title and body. OpenSearch Combined Fields uses BM25F to blend those fields into one relevance score. You'll learn how the pieces fit into a workflow that blends title and body evidence to rank documents with one score. I'm Professor Pi, teaching AI foundations with simple Python. Search systems often split text into fields. A headline and an article body live separately. That helps with display and filtering, but it causes a ranking gap. If a query has two words and one appears only in the title while the other appears only in the body, two separate BM25 calls may fail to combine that evidence. The result is an overlooked or badly ranked document, even though the content as a whole matches. OpenSearch's Combined Fields query implements BM25F, which treats multiple fields like one scoring surface, so split evidence actually counts together. Think of it like a jury. You want the title and the body to pool their votes, not vote separately and cancel each other out. In practice, this cuts false negatives and boosts documents where the headline calls out one idea and the body backs it up. It's especially useful for news, product search, and FAQs where short titles and longer bodies both matter. The trade-off is you still need to tune how strongly the title should dominate the score. We will build a tiny demo that shows the failure, then fix it with combined fields. You will see a baseline that misses split matches, and then the BM25F style result that recovers them. Quick note: this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. Now we start by connecting to a local OpenSearch instance to make sure the service is reachable. This snippet connects Python to a local OpenSearch cluster and checks that it responds. Before we worry about ranking, the usual failure is simply a dead client. Client.ping gives that tiny health check. The OpenSearch object becomes the shared client for every step that follows, and the visible Boolean output tells you if the connection is ready, so later examples focus on relevance instead of connectivity. Now that the client is healthy, we need an index shape that separates title and body and marks them as text fields. This example creates the OpenSearch index that will hold separate title and body text. BM25F needs analyzable text fields, so the mapping declares both as text and keeps the lesson visible. The code uses client.indices.exists, client.indices.delete, and client.indices.create, so the demo is repeatable, and the acknowledged response shows the search surface is ready. This step only prepares the shape of the documents, so OpenSearch can compute term statistics per field and across fields later. With the index ready, we need documents that purposely split query terms across title and body, so the contrast becomes obvious. This code loads a tiny OpenSearch collection where query terms land in different fields. One article puts vector in the title and search in the body. Another has both words in the title, and a third flips the pattern. That split is the point. The loop calls client.index with stable IDs, and then client.indices.refresh to make the right searchable for the next step. The visible document count confirms the ranking examples have real data to exercise. Next, we run a straightforward baseline search that treats fields independently. This shows the problem we need to fix. This snippet uses OpenSearch client.search to show why a field-by-field baseline can be too strict. With multi-match set to best fields and operator and, both query terms must match inside the same field candidate. That means the article where vector is in title and search is in body can be missed, even though the record clearly matches across fields. The visible output shows only same field matches, which motivates a unified title-body query. Now, we swap to combined fields so title and body act like one document for BM25 scoring, and we add a title weight. This example runs the OpenSearch combined fields query that turns title and body into one BM25F scoring problem. The operator AND still requires both terms, but now those terms can be satisfied across either field, so split matches are preserved. The fields list also gives title a weight with title squared, keeping headline matches influential without throwing away body evidence. The visible output shows more matches than the baseline, which is the practical payoff of pooling fields for BM25 style scoring. In a real project, you would map this toy logic to your article pipeline, push titles and bodies into the same index, keep a small test set with split queries, and run combined fields with different title weights to watch how ranking moves. That mirrors how QA checks relevance before rollout. Use combined fields when you need evidence to flow across fields, when titles, summaries, and bodies each carry complementary signals. Watch the title weight closely because it controls how much short fields dominate. One caveat: pooling fields can hide per-field diagnostics, so keep tests that isolate title-only and body-only scoring. To improve this example, tune BM25, K1, and B on your index. Try a small grid search over K1 and B on a held-out validation set that includes split match queries, and choose the pair that maximizes your ranking metric. If AI Foundations in Python help, subscribe and watch the AI Foundations videos.